Hey there, astronomy. This is Miss Reork. Alright, so to finish up chapter 16, let's talk about how galaxies interact, because they do interact with each other. Alright, inside of some galaxies, they have black holes. Some galaxies, like our own, they believe have supermassive black holes. Oh yeah. Alright, so how do they know this? Well, the stars near the center of the galaxies orbit at extremely high velocities, and because they're orbiting at the extreme high velocities, but they kind of get veered off course every once in a while, and they speed up and then they slow down, it suggests the presence of a supermassive black hole in the center. Right? The mass of a galaxy's supermassive black hole is going to be proportional to the mass of its nuclear bulge. So that shows that the supermassive black holes must have formed when the galaxy was formed. Okay, so from, again, what I just said, mass in the very center must be from a black hole because, well, there's nothing else there that could have that mass in that small space. Several million or up to more than a billion solar masses means that it's a supermassive black hole, which is what they think is in the Milky Way. All right, dark matter. Dark matter, if we can see stars, we can see interstellar gas, we can see the dust, we see those things, but then there's a lot of stuff in there that we can't see, and that is what we would call invisible or dark matter. Observations of the galaxies shows that they contain 100 to 100 or 10 to 100 times more dark matter than visible matter. 95% of the universe, they say, is made up of dark matter. Whew. And the nature of this dark matter is not really understood at this time, so we're going to keep going. Okay. Okay, clusters of galaxies. So galaxies don't like to be alone. They like to be with their friends. And so they'll usually exist in what we call clusters, okay, or groups of galaxies. So you can have rich clusters where they have, these are the really popular ones. They have like 50 million followers and, they're so famous. They have 1,000 or more galaxies, a diameter of about 3 megapixels, or pixels, that was cute, parsecs, and they're condensed around a large central galaxy. Well, what about the poor clusters? These are like your mom and your dad, and they only have like 3 followers. It's really sad. I know. Less than 1,000 galaxies, or sometimes just a few galaxies. They have the diameter of a few megaparsecs, and they're not usually condensed towards the center of anything. All right, so these galaxies, the space between these galaxies is not empty. We think it is, but it's not. Okay, what's it filled with? Hot gas, and this hot gas you can observe using X-rays. Okay, so in visible light, this is what we would see. If we were to take that and blow it up, we see this in X-ray. See how much more stuff there is? There's so much more stuff in there. Yeah. Okay, because we can't see the dark stuff. That's why, the hot gas. All right. This gas remains gravitationally bound to where it's at, and that provides more evidence for our dark matter. All right, our galaxy cluster is called the local group. I know, the local group. That's cute, right? Okay, so the Milky Way galaxy is here, right? And then we have, hold on, where are we at? And the Andromeda galaxy is here. That's one of our neighbors, okay? And then we have, I don't see it. Sagittarius dwarf. No. I don't see the other one. That's okay. Maybe it's M33. Okay, so this is our galaxy, the local group. The Milky Way is there. The Magellanic Clouds are there. The Andromeda galaxy. Those are all parts of our galaxy. Okay, these neighboring galaxies are groups of local galaxies. Sometimes they're difficult to observe because they're located behind the center of our galaxy. And why can't we see the center of our galaxy? Because of all the dust and gas. So why can't we see the neighboring galaxies? Because of all the dust and gas. All right. So it makes it a little hard to see. Makes it a little hard to see them all. But there is a Sagittarius dwarf galaxy back here. It's really hard to see. The center of our galaxy is actually to the right of Sagittarius. You'll see the Milky Way going all over the place, and Scorpius is right below it. So if you're ever looking to see if maybe, just maybe, you can see the center of the galaxy, that's where you need to look. All right, we have the Canis Major galaxy. Canis Major is a dwarf galaxy. It orbits around the Milky Way a couple times and has tidal forces. And these tidal forces are going to rip away stars and gas as they go around. Yeah, not cool, right? Not cool, bro. All right. When galaxies interact. All right, so how do they interact? Well, these rich clusters, these rich clusters of galaxies, they are the ones that are going to collide and interact the most. These galaxies can produce ring galaxies and tidal tails. Yeah, I know, heavy stuff, right? Um, Galaxy collisions can twist and distort the shape of a galaxy and can trigger these star formations. So the starburst galaxies are popping up all over the place, right? And astronomers are able to use computer simulations to reproduce these galaxy interactions. For example, this right here, this is the tidal tails of the mice. Okay, computer simulation shows how it happened. Okay, other simulations of galaxy interactions. Here is two disk galaxies that pass near each other, and how as they pass near each other they pull on each other with gravity and it distorts their images and their shapes. Okay, here's another one, galaxy interactions with shells. Okay, um, when two galaxies get too close, sometimes they merge. Yeah, so NGC 7252 is probably the merger of two galaxies that happened about a million billion years ago. Okay. The small galaxy that's left is the center, and it's rotating backwards because of that big smash that happened when the two came together. So, let's see. Here's another image of another one, radio image of M64. The central region is rotating backwards. Again, another one's rotating backwards. This one has multiple nuclei that happen in that giant elliptical galaxy that got formed. So, let's see. Spiral galaxies are going to be very thin and delicate with disks, and they appear not to have suffered mergers with larger galaxies. But galaxies moving through the gas in a cluster of galaxies can be stripped of its own gas and dust and may become an SO galaxy. Remember? SO galaxy. All right. Large galaxies can absorb smaller galaxies in something that we call galactic cannibalism, and the small galaxy is completely swallowed by the larger one. Yes. So what happens? We've got two galaxies, one large and one small, that kind of come together. The larger one's going to be kind of swallowed up. We call it galactic cannibalism because one galaxy is eating another galaxy. If a human ate a human, we call it cannibalism. Okay. And then starburst galaxies are galaxies in which stars are being born at a very high rate. Okay, so here's some pictures of some starburst galaxies, and they contain many young stars and recent supernova, and are often rich in gas and dust. They're bright in the infrared, bright in the infrared. And then here's some of the furthest galaxies that we have been able to take pictures of. Okay, visible by HST. What's HST? I can't remember. Oops. And are seen at a time when the universe was only about 1 billion years old. Only? Oh, okay, so young. All right, so that's it, ladies and gentlemen. I'll see you in class.